Hi everyone, welcome back. Today I'm going to talk about another important topic that's called fuel. Now I'm going to talk about what is fuel and what are the classification, how they are graded, and what are the factors which involve in the characterization as well the classification of fuels. Alright, so fuel is nothing but a kind of substance. It may be a liquid or solid or in gaseous form. When it's born in the either controlled atmosphere and open atmosphere, it used to liberate considerable amount of heat along with some byproducts. Such kind of burnable carbon based material is called as fuel material. Now I'm going to talk about the classification, how the fuels are classified. So basically, based on the occurrence of the fuels are furtherly classified into two major classes, that is primary and secondary fuels. Now what are the type of fuels comes under primary fuels? So basically, based on the occurrence of the fuels, the primary fuels are also furtherly divided into three class like solid, liquid and gaseous state. The two based on the physical nature, physical state of the particular fuel material. Now, what are the substance comes under, what are the fuels comes under solid category? So the material which are available in the nature like coal is comes under solid type of fuel. And second one is liquid fuel, the petroleum products like the crude oil comes under this liquid fuel category. And the third one is going to be gaseous fuel, where natural gas comes under this category. Alright, now I am going to talk about little bit about the classification of coals. So basically, the material what we are getting from the nature can be further divided into the following four major category. And the classification is certainly based on the quantum of heat liberated by the unit quantity of the particular coal material, and amount of moisture content and amount of carbon content, and also the calorific value of the particular material. And accordingly, they are graded like peat. The second one is going to be lignite, and the third one is going to be a bituminous, and the fourth one is going to be anthracite material. So all this classification is entirely based on the calorific of the particular fuel. And the peat is one of the very impure form of coal, and the second one will be lignite, and the third one in terms of calorific value, and third one is going to be bituminous, and the last one is going to be anthracite. So anthracite is the very purest form of coal material, but in India what we are getting, maximum amount of fuel is going to be a lignite one. Even in Tamil Nadu also we do one coal mine which is situated in Kadalur districts, that is Neyveli, where we are getting a lignite coal. Alright, so this is all about the classification of coal based on the calorific value and the type of and the quantum of impurities like water content, moisture, sulfur content and other material present in the coal material. The second one is going to be petroleum products, the raw crude oil. When this petroleum is subject to distillation process, we can get different type of fuel depending upon the boiling point of the particular fuels. And third one is natural gas. The gas which we are getting the nature is called natural gas, and it can be used for various designated purposes. So that's all about the information about primary fuel. And the second one is going to be secondary fuel, and based on the physical state of the fuel, and here also it could be classified like solid, liquid and gaseous fuel. And here solid fuel is nothing but coke material. So basically coke is derived from the coal. So when you look at the chemical composition of coal, it found to have like carbon maximum amount and little bit of hydrogen and other substance like sulfur, nitrogen and other elements. And the coal as such cannot be used for various designated purposes. So therefore, because basically coke is nothing but a kind of material which is converted from coal, and this is called coal is nothing but hydrogen deficient material, and compared to the other hydrocarbons or the other petroleum products like diesel or petrol, the coal percentage, the hydrogen percentage in the coal is going to be only 4%. Now we have to convert the hydrogen deficient coal into coke material. So conversion of coal into hydrogen rich carbonous material is called as coke material. And liquid fuel is nothing but like petrol and diesel comes under this category, and it's a kind of synthetic fuel. So we are getting the petrol and diesel from the petroleum products after some modification process. And the last one is going to be a gaseous fuel, where LPG comes under this category. So basically under normal conditions, the LPG available in the form of gas only, In order to for the storage purpose, they are converting the gaseous form of LPG petrol, gaseous fuel into liquid form of petrol, liquid form of fuel. It's called liquefied petroleum gas. So basically, the major chemical composition of this LPG is going to be propane hydrocarbon. Basically, this LPG is odorless in nature. In order to identify the leakage in the domestic cylinder, during the filling process itself, they will be adding one more component called ethyl thiol alcohol, and this is while during the leakage process, this compound is responsible for the foul smell. So based on the smell, we can able to identify the leakage of the particular LPG gas. So that's all about the classification of primary and secondary fuel. And the second concept I'm going to talk about is calorific value. And before that, I just want to discuss about the good requisite for good fuel. So what are the properties the fuels must possess, or what are the basic quality it requires? We can call the fuel as a good fuel. So when you look at the characteristics of the fuel, it should have high calorific value. The calorific value of the particular fuel should be much more higher than the other fuels. And the second one, should not release much amount of toxic gas like sulfur oxide and nitrogen oxides. So basically, the X stands for maybe 1 or 2. Basically, the coal like the solid fuel like coal were found to have much amount of sulfur and nitrogen content. So when you burn this fuel in the atmosphere conditions, they used to emit much amount of sulfur and nitrogen oxides. If fuel emits such kind of toxic gas in the atmosphere, it will leading to the another important phenomena is called climate change factor, like global warming and acid rain process. Because when you emit much amount of such kind of toxic gas in the atmosphere conditions, this will try to contribute to the global warming process, as well as leading to the formation of acid rain. So acid rain is nothing but addition of such kind of toxic gas in the atmosphere, like sulfur oxides and nitrogen oxides in the atmosphere. When you release such kind of oxides in the atmosphere, they will undergo various modification process in the atmosphere during the long journey of travel, and it will attain the stable form of oxides. And once it attains the stable form of oxide, it will try to mingle with the water molecule, maybe available in the atmosphere conditions or during rainy season, and it will convert it into the corresponding acids like sulfuric acid, and the sulfur oxide will be converted to sulfuric acid, and the nitrogen oxide will be converted to nitric acid, HNO3. So therefore, such kind of acids contamination will be taking place in the water bodies. This is called acid rain process, acid rain phenomena. So therefore, the coal should not have the fuel should not have coal or liquid petrol, liquid fuels or gaseous fuels should not have such kind of sulfur nitrogen content in the chemical composition. And the third one is going to be the fuel should have low volatile matters, and ash content. If it is a solid fuel, should have very less ash content, and nitrogen content. So therefore, the good fuel should have very low amount of volatile matter, ash content, nitrogen content, as well moisture content. So this is very important for a good fuel. And the fourth one, and the good fuel should have low ignition temperature. Low ignition temperature. So basically, the ignition temperatures depends upon the quantum of hydrogen present in the particular fuel. It is directly proportional to the ignition. The hydrogen content is directly proportional to the ignition temperature. I stands for ignition temperature. If fuel found to have much amount of hydrogen, the ignition temperature will be very less. Okay. And also the coal should emit very less amount of carbon oxides, maybe like carbon dioxide and carbon monoxide, and it depends upon the quantum of oxides depends upon the amount of carbon content present in the particular fuel material. And another important parameter what we have to see is emission of CO. So if the fuel keep on emitting much amount of CO content, so we have to consider that we are supplying less amount of oxygen content during the combustion process. So therefore so that indicates that itself an indicator that indicates that insufficient amount supply of oxygen. So therefore we have to supply much amount of oxygen content to the combustion process. So when you supply much amount of oxygen to the combustion process, it will reduce the emission of CO, because the CO is one of the important toxic material when you introduce the CO into the atmospheric conditions, because when you inhale the CO, it will go and combine with the hemoglobin body, blood hemoglobin, and it forms carboxyhemoglobin substance, carboxyhemoglobin substance, that it so basically the function of blood in our body is it will try to transfer the oxygen to all the cells which is available in our body. But when carbon monoxide is inhaled by the particular person, it will have greater affinity, and it will go and combine with the iron which is present in the hemoglobin, and it forms a kind of carboxyhemoglobin toxic substance. So therefore the blood unable to transfer the oxygen to the other cells. So therefore if the CO percentage is less, then we will feel the suffocation. If the CO content is maximum, then it leading to the death also. So therefore during the combustion process, we should emit only very less amount of CO, carbon monoxide gas, into the atmospheric conditions. Calorific value. So the next topic is going to be calorific value. What does mean by calorific value? So the calorific value of any fuel can be defined as when unit quantity of material, maybe a liquid or solid form of fuel component, when unit quantity of material is burnt in the atmosphere air condition, it will emit some amount of heat. So that amount of heat is going to be a calorific value for the particular fuel. I repeat, calorific value is nothing but when unit quantity of the burnable substance is subjected to the combustion process, it will release some amount of heat energy. So that amount of heat energy is equivalent to calorific value of the particular fuel. And how the calorific value are classified, or how it can be measured, how the calorific value of fuel can be measured. So basically for the liquid and solid fuel, the calorific value is expressed in terms of calories per gram or kilocalories per kilogram. This is one thing. And for the gaseous fuel, the calorific value is measured by calories or kilocalories by meter cube. Kilocalories per meter cube. So these are the units are generally employed to measure the calorific value of the particular fuels. And what are the units are generally employed to represent the calorific value of any fuels? So the first one is going to be British thermal unit. This is based on European standards. So British thermal unit is nothing but when the amount of heat. So British thermal unit is nothing but amount of heat is required to rise the temperature of 1 gram of water to 1 degree Fahrenheit. 1 degree Fahrenheit. So that normally at room temperature, the temperature of the water is going to be about 60 degree Fahrenheit. Now we are going to rise the temperature of 1 gram of water to 61 degree centigrade. So the quantum of heat is required to rise 62 to 61 degree is called as British thermal unit. So this is the one unit is used to represent the calorific value of the fuel. And the second one, a centigrade heat unit. So this is the second unit is normally used to represent the calorific value of the fuels. Now, so basically in British thermal unit, we are not representing the quantum of water in terms of gram. We are going to represent the water content in terms of pound, POUND, pound. And centigrade thermal unit. So here also the amount of heat is required to rise the 1 pound of water to 1 degree Fahrenheit. 1 degree centigrade, not Fahrenheit. 1 degree centigrade is called as centigrade thermal unit. For an example, at room temperature, at normal and ambient condition, the temperature of water would be around 18 degrees centigrade. Now we are going to rise 18 to 19 degrees centigrade. So we are going to rise the 1 pound of water to 1 degree in excess. So that's called centigrade thermal unit. And the third one is going to be calories. Calorie is generally employed in our Indian system. So calorie is nothing but amount of heat is required to rise 1 gram of water to 1 degree centigrade. It's called as calories. And similarly, one more unit can also be used to represent the calorific value of the particular fuel. That's called kilocalories. So it's nothing but quantum of heat is required to rise 1 kilogram of water to 1 degree centigrade. So these are the 4 units are generally employed to represent the calorific value of the solid, liquid and gaseous fuels. And another important concept is going to be analysis of coal. How the coals are analyzed. So basically, depending upon the data required, we are going to do 2 type of analysis. The one is called proximate analysis and another is called ultimate analysis. Now, what are the information we can get it from the proximate analysis of coal? So as I mentioned earlier, depending on the data depending on data required, we are going to have 2 type of analysis. One is proximate and one is going to be ultimate. So when you perform the proximate analysis, we can able to get the following information. The first one is going to be amount of moisture present in the particular fuel. Amount of moisture present in the particular fuel and amount of ash content and amount of volatile matter and also amount of fixed carbon content present in the particular fuels. So when you perform the proximate analysis of any form of coal, like lignite, bituminous, peat or anthracite, we can able to get the following informations like amount of moisture content and amount of ash content and amount of volatile matters and fixed carbon content. All these information can be obtained by performing the proximate analysis. The second analysis is going to be ultimate analysis. So when you perform ultimate analysis, we can able to get the following information about the chemical nature of the. So this is all about the physical. It's all about the physical quantity. It tells about the physical nature of the fuel. And the second one, if you want to get the chemical composition of the fuel, we can go for the ultimate analysis. So by performing this ultimate analysis, we can able to get the percentage of carbon content and percentage of hydrogen content and percentage of sulfur content and percentage of nitrogen content and also the percentage of oxygen. So all these informations, all these elements can be identified with the help of ultimate analysis. So while you performing ultimate analysis, we can able to get all the informations. So if based on this, we can able to tell about the nature of the fuel. If the coal found to have a much amount of or huge amount of carbon content, is going to be pure form of coal. If the coal found to have much amount of sulfur and nitrogen content, then we can say that it is kind of the impure form of coal, because if sulfur and nitrogen is more, it used to emit a different type of sulfur nitrogen oxides that will contribute to the global warming as well as the rain process. So therefore, based on the proximate and ultimate analysis, you can be able to get the various physical and chemical parameters of the particular coal material. Dear friends, with this I just want to conclude my today's topic, and in the next class I will be talking about the synthesis of synthetic petrol and cetane ember, octane ember and characteristics of diesel and petrol engines. Thank you all. Thank you very much.